Okay, this is Unit 4C, looking at savings plans and investments. This unit is scheduled to go 2 class periods long, and so this will be a little bit longer than normal, but again, this is meant to span 2 days rather than just a single day. There's just a heads up there because we're going to spend time talking about savings plans, and then we'll be talking about investments, and it's all kind of culminated in one lesson. So in this lesson, we got a little opening here. So suppose you want to save money, perhaps for retirement, for children's college expenses. So you can deposit a lump sum of money today and just let it grow using that power of compound interest that we talked about. But what if you don't have a large lump sum to start with for such an account? What should we do? Well, for most people, a more realistic way to save is by depositing smaller amounts on a regular basis. So for example, you might put $50 a month into savings, and these are what we these are what we're going to call savings plans. They're so popular that they have a lot of special names. Some even get special tax treatment, such as an individual retirement account, which is known as an IRA, 401k account, 401k plan, a 529 college savings plan, and the list goes on and on and on. There's tons of these things. And just as a little note we've got here is, by the way, financial planners call any series of equal regular payments an annuity. So if you do hear that that word annuity, just usually means you are looking something with equal monthly payments when you hear, if you do hear that word. So sometimes I may accidentally throw that word in there, but I'll try my best to follow this textbook that calls everything a savings plan. So we're going to use an example to see how these savings plans work. So suppose that you deposit $100 into a savings plan at the end of each month. So say you get a paycheck and you deposit $100 each at the end of each month. Keep the numbers simple. Suppose that your plan pays a monthly APR of 12%, which would be 1% every month. So here's how it would work out. You have $0 in the account. At the end of 1 month, you make a $100 deposit. So that's your first deposit. And so you don't make any interest off of that month. At the end of month 2, you receive the monthly interest on $100 already paid to your account, which is 1% of $100 or just $1. In addition, you make an additional $100. So here's how you calculate your balance. It's the prior balance from month 1 was $100, plus that interest earned on $100 was $1, plus your new deposit, so you're up to $201 in your account. Okay, and then you can continue this on. So after 3 months, you receive 1% on the $201. So you would get an interest of $2.01, and then you'd add in again another deposit of $100. So you take your prior balance plus your interest plus your new deposit, and it gives you $303.01. And again, this is a way a lot of people build up their savings accounts. So we can take a look at this. So here's what this calculation would look like over a 6-month period. And we could extend this thing out indefinitely, but that would take a ton of work if we were to run this through. So this, some table like this you may generate in Microsoft Excel or Google Sheets or something like that. However, there's a much easier way to do this, and this book calls this the savings plan formula. And if you'd like to read in your textbook, there is a derivation of this formula where it comes from. But in the end, here's where we are. So when you're working in a savings plan and you make regular payments, so the same payment every month, then the amount in there is going to be the payment times, and hopefully you recognize this thing, 1 plus your APR over n times n to the y, subtract 1, and then it's divided by the APR over n. Okay, and here are all the meanings of those variables, which we've talked about what all of those mean. PMT is the new variable we introduced here, which is your payment or your deposit amount. Okay, so again, as with compound interest, the accumulated balance, A, is often referred to as the future value, And then the present value is a starting principal amount, which is 0 in this case when we're looking at these savings plans, because we assume you start out with $0 and build up from there. Okay. So let's take a look at an example now. So a friend has an IRA with an APR of 6.25%. She started the IRA at age 25, deposited $100 a month. So write down a couple things here. APR is 0.0625. The payment or the deposit is $100. And we want to know how much her IRA will contain when she's retired at age 65. So she starts at age 25, ends at age 65, so the difference there is 40 years. So Y is going to be 40. And one last thing, we're putting in per month, so N is going to be 12, 12 months in a year. So we want to compare, so we're going to find out how much she will have in her IRA, and then we're going to compare that amount to the total deposit she actually made over that period of time. And we'll look at that here shortly. But first we're going to find the amount, which is again the payment of $100, and then that's times 1 plus your APR over how many times you're compounded to, or how many payments you make in a year, or deposits to the 12 times 40, so N times Y power minus 1, and then all of that is divided by your APR over 12. Okay, and then this big old number here, so I should put that right there, so it's 100 times all of this. Okay, now the careful thing you gotta be careful about here is you've got to be able to make sure you can get this answer in the calculator correctly. So again, scientific calculator, graphing calculator. Do not recommend a phone calculator on this, at least the basic phone calculators. So now we're going to multiply all of this out in the calculator, and once you do that, you should get something in the neighborhood of $213,191.25. And that's the amount after 40 years that will be in there, with an APR 6.25%, putting in $100 for 40 years. Now, to find out how much in deposits, so how much did you actually put in on your own, and then how much is interest? Well, the deposits, you made 12 deposits. Well, let's put it this way. $100, and they were 12 per year for 40 years. So if I do 100 times 12 times 40, okay, that is going to be $48,000. So you deposited $48,000 over the course of the 40 years, or your friend did, but you made, in the end, $213,191. So the amount that you earned in interest is just the difference of the two. 213.91.25 minus 48,000. So over the course of all of this time, your money was working for you in this account, and you made $165,191.25 just off of interest. So here's the amount of deposits, what it asked us, and then just for curiosity, that's how much you make in interest. So now that's a look at using the savings plan formula when we're trying to find an amount after a certain period of time. Now, sometimes we need to plan ahead. So a lot of people will start with a particular goal in mind, such as saving enough for a retirement, new car in a couple years. And so in these scenarios, when you have a financial goal, that is your total amount A. And that's the amount you desire after a certain number of years. And we need to determine, so if I have that goal, what regular payments are needed to reach the goal. So I actually only have one example, so sorry that I put 2 there, but the following example will show you how that calculation works. Here's the formula. If you're wondering where that comes from, all it is it's taking our original payment formula right here, or excuse me, savings plan formula, and it's solving for payment. So really we're just dividing by this fraction on both sides, which is timesing by the reciprocal. So you'll notice that thing, this thing right here is just flipped and multiplied by a when you're solving for payment. Okay. But it's easier to see it that way as we are going to be plugging in these numbers. So at age 35, you start saving for retirement. So we know at age 35, okay, you still need to read more to get some information. If your investment plan pays APR of 6%, so 0.06 on that one, and you want to have $1 million, so you want to have an amount or a future value of $1 million when you retire in 30 years. How much do you deposit monthly? So again, monthly, we're looking at it as 12. So our payment is going to equal, I'm going to change colors here. So again, here's your payment. It's the amount you want, so 1 million, then times all of that good stuff, and I am definitely not going to have room right there. So payment is going to be 1 million. Okay, and then that's going to be multiplied by the APR over the number of months, or months in a year, which is 12, divided by, and this is where you got to be careful in your calculator. So you do 1 plus 0.06 over 12, and then that's all raised to the 12 times 30 power, because we're working for 30 years, and then subtract 1. So you got to be very careful with your parentheses when you're doing these calculations, but as you do all of that out, you will get a payment of $995.51. So that would be the monthly amount you need to put in for 30 years in order to reach your goal of $1 million at 6% APR. Okay. So next we're going to be looking at the total and annual return on an investment. Sorry, I'm just checking how much time we got in here. So in the examples that we've looked at so far, we've assumed that you get a constant interest rate over a period of time. In reality, interest rates are going to vary over time. They'll vary by day, by month. So, if we look at a case where you initially deposit $1,000 and it grows to $1,500 over 5 years, although the interest rate may have varied over the 5 years, we can still describe the change both in total and annual terms. So how much did it increase in total, and then kind of what was that rate at which it grew. So the total return is just the percent change in the investment value over that 5-year period. So we have our new value minus our starting principal divided by our starting principal times 100% to get a percentage. So from $1,500 to $1,000, excuse me, $1,000 to $1,500, that's an increase of 50%. So we can say that over 5 years, our investment grew and had a return of 50%. Now, the new value minus the starting principal, well, the new value, when we're looking at our savings, the new value is just the future value, or the amount that we want in the end. The starting value is the principal. So a simpler way to write this is just A minus P over P, and then times by 100% to get us 100%. That'll give us the total return in percentages. Then next, we have the annual return, is the APY that we talked about in the previous lesson. That would give the same overall growth in Y years. So this is just going to look at our percent growth on average over a year. So our annual return is found by taking A divided by P, raising it to the 1 over Y power, and then subtracting 1. And you don't need to know where that formula comes from in this class. Um,